Alright, this is recording number 2 for Chapter 1 of the Systems Engineering Handbook. For Chapter 1, the Systems Engineering Handbook Scope, Section 1.1, Purpose. This handbook defines the discipline and practice of systems engineering for students and practicing professionals alike, and provides an authoritative reference to understanding the SE discipline in terms of context, content, and practice. 1.2 Application. This handbook is consistent with ISO, IEC, IEEE 15288 2015. Systems and Software Engineering, System Lifecycle Processes, hereafter referred to as ISO, IEC, IEEE 15288. To ensure its usefulness across a wide range of application domains, man-made systems, and products, as well as business and services. ISO, IEC, IEEE 15288 is an international standard that provides generic top-level process descriptions and requirements, whereas this handbook further elaborates on those practices and activities necessary to execute those processes. Before applying this handbook in a given organization or project, it is recommended that the tailoring guidelines in Chapter 8 be used to remove conflicts with existing policies, procedures, and standards already in use within an organization. Processes and activities in this handbook do not supersede any international, national, or local laws or regulations. This handbook is also consistent with the Guide to the Systems Engineering Body of Knowledge, CBOK 2014, hereafter referred to as the CBOK, to the extent practicable. In many places, this handbook points readers to the CBOK for more detailed coverage of the related topics, including a current and vetted set of references. For organizations that do not follow the principles of ISO, IEC, IEEE 15288, or the CBOK to specify their lifecycle processes, including much of commercial industry, this handbook can serve as a reference to practices and methods that have been beneficial to the SE community at large, and that can add significant value in new domains. If appropriately selected and applied, Section 8.2 provides top-level guidance on the application of SE in selected product sectors and domains. Section 1.3 Contents. This chapter defines the purpose and scope of this handbook. Chapter 2 provides an overview of the goals and value of using SE throughout the system lifecycle. Chapter 3 describes an informative lifecycle model with 6 stages: concept, development, production, utilization, support, and retirement. ISO, IEC, IEEE 15288 identifies 4 process groups to support SE. Each of these process groups is the subject of an individual chapter. A graphical overview of these processes is given in Figure 1.1. Technical processes, which is Chapter 4, includes business or mission analysis, stakeholder needs and requirements definition, systems requirements definition, architecture definition, design definition, system analysis, implementation, integration, verification, transition, validation, operation, maintenance, and disposal. Technical management processes, which is Chapter 5, include project planning, project assessment and control, decision management, risk management, configuration management, information management, measurement, and quality assurance. Agreement processes, which is Chapter 6, include acquisition and supply. Organizational project enabling processes, which is Chapter 7, include lifecycle model management, infrastructure management, portfolio management, human resource management, quality management, and knowledge management. This handbook provides additional chapters beyond the process groups listed in Figure 1.1, which include tailoring processes and application of systems engineering, which is Chapter 8, include information on how to adapt and scale the SE processes and how to apply those processes in various applications. Not every process will apply universally. Careful selection from the material is recommended. Reliance on process over progress will not deliver a system. Cross-cutting systems engineering methods, Chapter 9, provides insights into methods that can apply across all processes, reflecting various aspects of the iterative and recursive nature of systems engineering. Specialty engineering activities, which is Chapter 10, includes practical information so systems engineers can understand and appreciate the importance of various specialty engineering topics. Appendix A contains a list of references used in this handbook. Appendices B and C provide a list of acronyms and a glossary of SE terms and definitions, respectively. Appendix D provides an n-squared diagram of the SE processes showing where appendices exist in the form of shared inputs or outputs. Appendix E provides a master list of inputs and outputs identified for each systems engineering process. Appendix F acknowledges the various contributors to this handbook. Errors, omissions, and other suggestions for this handbook can be submitted to the INCOSE using the comment form contained in Appendix G. Right, I'm going to go back to figure 1.1. And this figure is the four process groups identified in ISO IEC IEEE 15288 to support systems engineering, which are the first group, technical processes, the second group, technical management processes, the third group, agreement processes, and the fourth group, organizational project enabling processes. In the first group of technical processes, you have business or mission analysis process. You've got stakeholder needs and requirements definition process. You've got systems requirements definition process. You've got architecture definition process, design definition process, systems analysis process, implementation process, integration process, verification process, transition process, validation process, operation process, maintenance process, disposal process. Within technical management processes, the second group, you've got project planning process, project assessment and control process, decision management process, risk management process, configuration management process, information management process, measurement process, quality assurance process. In the third group, agreement processes, you've got acquisition process and supply process. In the fourth group, you've got organizational project enabling processes, which include lifecycle model management process, infrastructure management process, portfolio management process, human resource management process, quality management process, and knowledge management process. And again, there was figure 1.1, system lifecycle processes as per ISO IEC IEEE 15288, and it is an excerpt from ISO IEC IEEE 15288 from 2015, figure 4 on page 14, with permission from the ANSI on behalf of the ISO. Copyright ISO 2015. Going back to the text of the book, we've got section 1.4, format. A common format has been applied in chapters 4 through 7 to describe the system lifecycle processes found in ISO IEC IEEE 15288. Each process is illustrated by an input process output diagram, IPO diagram, showing key inputs, process activities, and resulting outputs. A sample is shown in figure 1.2, which is this one right here. Note that the IPO diagrams throughout this handbook represent a way that the SE processes can be performed, but not necessarily the way that they must be performed. The issue is that the SE processes produce results that are often captured in documents rather than producing documents, simply because they are identified as outputs. To understand a given process, readers are encouraged to study the complete information provided in the combination of diagrams and text and not rely solely on the diagrams. I'm going to go back up here. So you've got 4 different things. You've got 3 things feeding into activities. You've got inputs, controls, and enablers. And you've got the outputs coming out of the activities. The inputs might include something along the lines of data and material. Controls might imply might include applicable laws and regulations, standards, agreements, project direction, project control requests, and then enablers might include organizational policies, procedures, and standards, organizational infrastructure, project infrastructure, and a knowledge management system. The activities are some process, it can be any process, and then that process is an integrated set of activities that transforms inputs into desired outputs. So you could consider that as like cutting a piece of wood into different sized pieces and specific shapes. The outputs includes process data and or products and or services. Figure 1.2 is the sample of an IPO diagram, input process output diagram, for systems engineering processes. INCOSE SEH Systems Engineering Handbook, original feature created by Shortell and Walden, usage per the INCOSE SEH notices page. All other rights reserved. And then going back to the text, the following heading structure provides consistency in the discussion of these processes. You got the process overview, the purpose, the description, the inputs and outputs, the process activities, and process elaboration. To ensure consistency with ISO, IEC, IEEE 15288, the purpose statements from the standard are included verbatim for each process described herein. Inputs and outputs are listed by name within the respective IPO diagrams with which they are associated. A complete list of all inputs and outputs with their respective descriptions appear in Appendix E. The titles of the process's activities listed in each section are also consistent with ISO, IEC, IEEE 15288. In some cases, additional items have been included to provide summary-level information regarding industry best practices and evolutions in the application of SE processes. The controls and enablers shown in Figure 1.2 govern all processes described herein and, as such, are not repeated in the IPO diagrams or in the list of inputs associated with each process description. Typically, IPO diagrams do not include controls and enablers, but since they are not repeated in the IPO diagrams throughout the rest of the handbook, we have chosen to label them IPO diagrams. Descriptions of each control and enabler are provided in Appendix E. Definitions of frequently used terms, Section 1.5. One of the systems engineer's first and most important responsibilities on a project is to establish nomenclature and terminology that support clear, unambiguous communication and definition of the system and its elements, functions, operations, and associated processes. Further, to promote the advancement of the field of systems engineering throughout the world, it is essential that common definitions and understandings be established regarding general methods and terminology that in turn support common practices. As more systems engineers accept and use common terminology, systems engineering will experience improvements in communications, understanding, and ultimately, productivity. The glossary of terms used throughout this book, see Appendix C, is based on the definitions found in the ISO, IEC, IEEE 15288, or ISO, IEC, IEEE 24765, Systems and Software Engineering Vocabulary, 2010 version, and the SE Vocab 2013 version. That was the end of Chapter 1.